I would like to introduce Greg Lamp. He is from yhat, and he has flown here from New York to give us a great talk on ggplot. So please give him your attention. Let's get through this, and we will try and leave a little space for questions at the end. So go ahead.
OK. Can you hear me OK? Good. All right, great. So I'm Greg, here to talk about ggplot today. I'm up here. So we'll go over just what ggplot is, in case you're not familiar with it. I'll talk a little bit about some other libraries, how it compares to things like Matplotlib or D3. I'll explain how it works, sort of the best practices around using it, walk you through some use cases, and then we'll go into a tutorial just in the IPython notebook. So like I said, I'm Greg. I'm the CTO and co-founder of yhat. yhat is a startup. We're in New York. And we help companies manage and deploy their predictive analytics. And I won't plug it anymore. We'll go back to ggplot now. OK, so what is ggplot? Well, ggplot was originally implemented in R by a guy named Hadley Wickham, if you're familiar at all with R. He's built a lot of really great packages that are extremely helpful in doing just some of the routine and mundane stuff in data analytics. And ggplot is based on a book called The Grammar of Graphics. And what it is it's basically a domain-specific language for producing visualizations, particularly for data analysis. So think of all of the things that you've done when you're building a plot or you're analyzing some data. Stuff like making scatter plots, histograms, assigning colors to particular variables, customizing titles, labels, all of these things. You're doing them, you're writing a lot of code for it. Typically, it's sort of code that you reuse over and over and over again. And so instead of duplicating that effort, what ggplot does is it condenses all of that down into its own library, its own package, where you can take that functionality and abstract it and make it a lot easier and quicker to work with. So a lot of questions you might ask is like, well, what about Matplotlib? Like, Matplotlib's been around for a while. And I agree, like, Matplotlib is a great library, but I think it's a little bit out of date. There are some things that I really like about Matplotlib, but some of the things I don't like are just like the syntax and API I find a little bit cumbersome. It requires a lot of looping, which is sometimes a little bit awkward when you're making plots. And in addition, it's tough to learn, in particular for when you're taking someone who's coming from R or someone who's coming from even something like Excel and trying to learn scientific Python. It can be extremely difficult and frustrating for them to learn Matplotlib. And as a result, a lot of them just go back to R. So we've got sort of the parts about Matplotlib that I'm not crazy about. But there's a lot of things that Matplotlib does really, really well. So it's been around for a while. It's extremely mature. There's some really great project maintainers, and they do a really good job in terms of just testing and stability. It's got great integrations with the IPython notebook. I think everyone has seen some of these great presentations where everyone's using the notebook and everyone's got Matplotlibs, and there's Bokeh and all these other plotting libraries now. And then in addition, like, you've got extremely customizable charts where you can place like particular labels or annotations or what have you on your graphics, and all of that can be done through the API. So we've got the good, we've got the bad. Let's figure out a way to take those good things and really use them. And so just to give you a really quick example of sort of meeting the bad parts of Matplotlib with the great parts of ggplot. So Greg Rita, he's an analyst at Grubhub. He's a really cool guy. I've talked with him a few times. But on his blog, he has this quote I like. It says, "Facet all things." And faceting, it allows you to break down different variables or components of a data set and really break them out into individual kind of plots right here and really get a good sense for what your data set looks like without having to actually inspect, what would this be, like 30 individual plots. And so it's a great way, it's a great technique for data analysis. We'll do it a little bit later in the tutorial part. But to do this in ggplot, it is 2 lines of code. It's really easy. Whereas to do this in Matplotlib, you got to write a bunch of loops. There's like adding labels, removing labels. There's a lot going on. Oops. So you've got Matplotlib, and there's also D3. And D3 is great. I'm sure you've all heard of it and seen it. It produces great, high-quality visualizations. A lot of times they're interactive. And this is the kind of stuff that you see on the New York Times that my mom will give me a call and be like, oh, did you see that chart about like life expectancy in Texas or whatever? And when you think of ggplot's kind of at the other end of the spectrum. Whereas you've got D3, where you're going to be working maybe like a whole week on building this one really killer visualization that you're going to send it to all your friends. It's going to get nuked on Reddit. It's going to be on Hacker News. Everyone's going to be talking about it. ggplot, you're going to build 1,000 plots and not share them with anybody. You're going to throw them all away. And maybe there's going to be one that you take and you send it out in an email and you send it out to the marketing team and the head of marketing is like, oh, it looks like an interesting trend. But so think of it as like ggplot, disposable, really quick to use, but it's still extremely valuable. D3 is more like you're building this painting that you're really going to want to show off. OK, so hopefully you're sold on using ggplot. Tell you a little bit about how it works. So you think about, like, I'm telling you all these great features you're going to get out of ggplot. So there has to be some sort of trade-off. And in this case, the trade-off is your data format. You really have to use pandas if you want to get really all the features out of ggplot, which I think for most people in this room, that is fine. Like, everyone's using pandas, has a great API, makes it really easy to manage your data. So you have to use pandas. There are ways that you can use NumPy arrays and lists, but honestly, I wouldn't even bother with it. Stick to pandas. And so what it looks like is you create a ggplot, pretty simple, object initializer here, put your data frame. In this case, I'm just using a built-in one here. And then you accompany that with aesthetics. And we abbreviate that as AES. And so aesthetics are how your plot looks, and it describes a way for you're just basically giving ggplot instructions for how to build and create your plot, defining the x-axis, defining the y-axis, that sort of thing. So this example, we've got a data set that has US meat production over time. But you can see we've got the x-axis is the date, and that winds up going there. And then the y is our beef, or the production of beef. And all that's getting extracted out by ggplot, making this great looking plot. And so there's other things that you can, or other aesthetics that you can also use. You can have color, shape, size. There's a lot. Some of them are shared between the different types of plots. Others are more custom. And we can get into that a little bit more in the notebook. OK, so geom, stats, and scales. These are the building blocks of your plots or of your visualizations. And what I mean by that is you take something like a scatter plot. In ggplot, that's represented as something called geom point. And so when you add a geom point to your ggplot, you're going to get something that looks like this. And again, there's a lot of different types of geoms. I'm not going to get into them all right now, but just know that there are very many. Again, same sort of thing, but instead of your typical bar plot, histogram, what have you, there's another notion called a stat. Stats are simple statistics that are commonly performed on your data set. Most common one that I use is just stat smooth, where you apply a trend line to your data. And there's a few others that come in handy. You can actually define your own custom one just using the stat function. And then lastly, we have scaling your data. So it's not just enough to create these plots. You also want to be able to customize the look and feel, add different colors, different types of, maybe you want a log scale, maybe you want some other label or some other color mapping for your data. Scales allow you to do that. All right, so we've got the ggplots, we've got the aesthetics, we've got geoms and stats. The last concept that's key and really brings everything together are layers. And so what layers are is you can think of when you first create that ggplot object where you say ggplot, my data is this cars data set. I'm going to have an aesthetics of an X and a Y. That's sort of your base layer. And all that is you're just defining a coordinate grid. And it looks something like this. And then from there, you work up and gradually add additional features or additional functionality to your visualization. So you might want to add some points to that. And then you might want to take that and add a trend line. And the great part about ggplot, or at least what I really like about it, is that is really expressed in the syntax. So the syntax, you're quite literally adding these components together, which is exactly how it's playing out in your code. And so when you add all this together, you get a plot that has points, it has a smooth curve overlaid over those points, and you can go from there. So why is this all great? Well, one of the things that I really like when I'm using ggplot is that it makes some reasonable assumptions for you. So things like we have this field. It's got two categorical variables, project alpha, projects alpha. If you throw this into Matplotlib and assign color to this field, it is going to flip out, give you this nasty stack trace, and really, really all you want is to just have two different colors. And so ggplot, same sort of thing, defining this plot, adding in that colors field, and it just sort of knows, it identifies like, hey, it's a categorical variable. It's not explicitly a color like red or blue, but what it probably means is that we're going to want two different colors for each category. Another great thing about ggplot is that you can get a lot of features and be extremely particular about what's going to happen in your plot without having to write a lot of code. So for example, in this little snippet here, we're defining the X parameter, a Y parameter. We're actually creating a formula in the color field so that we're going to cast the cylinder or CYL field from a numeric type to a categorical type. And then we're going to add a scatter plot to it. And it looks like this. If you were going to do the same thing in Matplotlib, you're going to have a lot of looping going on. You're going to have to manually define labels, title. You're going to have to invoke the scatter command a few times. And in general, there's just a lot more code that you need in order to generate what I consider to be a pretty simple graphic. And then the last thing is, I think it looks pretty good. So, I mean, don't credit me. Like, Hadley Wickham built all these styles. I just kind of copied it. But I think they tend to look pretty nice. They're nice enough that you can put them in publications, and you don't feel embarrassed if you're sending it out to other members of your team. And it's also extremely easy to customize. So, for example, I really like the way that Seaborn plots work. I think there's a talk on that either later or it already happened, I'm not sure. But it's a great library, you should check it out. And anyways, I saw it and I really wanted to be able to do that from within ggplot. So it took me about 30 minutes. I copied a bunch of the code from the Seaborn project, just sort of pasted it into a single file, and all of a sudden, I could make Seaborn plots from ggplot. OK, so since this is technically a tutorial, I want to launch into the IPython notebook for a little bit here. OK, so if you want to follow along, feel free. There's a GitHub repository. It's on my personal GitHub, glamp/ggplot tutorial. And you can also, there's a blog post, I just threw it up today on our yhat blog that has the NB viewer links for all of these notebooks and also a link to the GitHub repo. OK. So since this isn't a talk about pandas, I'm not going to go over cleaning and formatting all the data that we're going to use. Just know that we're using a data set that comes from Major League Baseball. It's called PitchFX. It's really cool. It's, well, granted, I really like baseball, but I think most people that I show it to, even that don't like sports, think it's cool. It's all public. It's updated very, very regularly. It might be in like real time or close to real time. I'm not sure. But it's kind of funny. You can just go on MLB.com, and if you figure out the link structure here, it's basically just a big Apache or something or other, bunch of XML files. And they contain information on pitches in Major League Baseball games. And we won't go through this. We'll skip to the part where we got it all cleaned and in a nice format. But check it out. There's a couple of really good R packages. And then there's also a Ruby client for extracting the data. And they work really well. All right, I'm going to zoom in. Is that big enough? You guys see it? All right, cool. All right, so getting started with ggplot. Pretty simple. I typically just import everything in the global namespace. I've seen some people using it where they'll do like import ggplot as gg, but we haven't reached PyData status yet where you have like the convention that everyone seems to follow. So for now, I recommend just doing from ggplot import everything. There's a few data sets that ship with the package. One is my sort of personal favorite. It's a meat data set, and it's just meat production in the United States over the past half century or so. And it's great for time series. It's really simple. Pretty much anyone is going to see it and understand what's going on. And then there's also a couple that ship with the R version of ggplot as well. One is just a diamonds data set. Again, pretty simple, some basic features about some diamonds. And it's great because it has a nice mix of categorical and numerical features. Makes it good for doing demos, making slide decks. And then a couple others, feel free to check them out. OK, so got ggplot here. The way that you're typically going to be interacting with it is through this ggplot class. It is technically a class, although you will interact with it much more like you would a Python function. Typically don't call like dot methods from ggplot. And it takes two arguments. One is, like we mentioned, a data frame. The other are some aesthetics. You can put them in either position. I typically do this, although that's just my personal preference. And kind of like I was talking about earlier, you create a ggplot, and if you were to try and render that just as it is, you're going to wind up with, just a big blank grid. So, aesthetics. Talked about it a little bit in the presentation. Aesthetics allow you to really define and coordinate what your plot is going to look like. It's essentially just a dictionary with a couple of special properties. There's a list of available aesthetics for each geom and each stat on the documentation. But typically, you've got X and Y. You can use shorthand, and it'll assume that the first argument is X, the second argument is Y, the third argument is colors. You see that here. It also supports PATSI formulas. So I don't know how many of you are familiar with PATSI, but you can do things like basic arithmetic, and you can cast categorical variables using factor. All right, so let's actually start doing some plots. So that's what you're probably here for. Zoom out one. There we go. All right, so we've got our base plot here. Actually creating a scatter plot, you're going to literally quite take your base ggplot object and add a geom point or add a scatter plot to it. And that gives you something that looks like this. So pretty simple. You can make one. Let's go back, get a little bit more complicated. Where am I here? Here we go. OK. Yeah, I want to leave. OK, so now we're going to get into that baseball data set that I mentioned. It's got some pretty cool information in here. So I'm going to limit it to just a few columns. There's like 50 columns, and it's kind of information overload if you don't know what you're doing. But it's got some cool stuff like basic information about the game, hitter, pitcher. These two coordinates, P, X, and PZ, define where the pitch actually landed in the strike zone. And then they also have, I guess they just have like an army of data entry people categorizing all of these pitches that are happening, getting the radar gun, how fast they're going, all that good stuff. Make sure I run that. Cool. OK, so use case here, I want to walk through this data set, and I'm just going to show you how I use ggplot to explore a data set, investigate a couple of questions that might arise as a result, and show you how you can dig a little deeper and leverage some of the more advanced features of ggplot. So really basic. First thing I want to see is the strike zone data sounds kind of interesting. I wonder what it actually looks like. And so you can see you've got this giant blob of data. And this is one of those instances where just because you have a data set that has 200,000 observations, that doesn't mean you need to plot every single one of them. If you wind up with this giant mess of points, it's not super helpful. So what we're going to do is try and investigate some relationships on subsets of that data. Again, looking at just speeds of the data, you can see that it's sort of just this mess of points. So what are some ways that you can take this data set and actually use it and get some helpful information out of it? So one is histograms. I make histograms all the time. They're extremely useful, great way to get a high-level view of what's going on with a particular variable. For this one, I'm going to look at the speed of the pitch. It's called start speed. It's the radar gun reading when the pitcher releases the ball. And so you can see we've got data distributed from roughly 70 to 100 miles an hour, maybe one or two above 100. And most of them are right around here, somewhere between 90 to 93 miles an hour. And so that makes sense to me. And I checked out, just sort of looking to corroborate that. I looked at source of all wisdom, Yahoo Answers, and you can see that you got other people agreeing. So it seems to make sense. But what if we wanted to break that down and say, all right, so what about for different pitches that a pitcher might throw? What are the speed distributions looking like? And so a bad way to do that would be to loop through a pandas group by, and you get the desired effect of finding that you get all these histograms for each one of your pitches, but it's really hard to read. And a much better way to do that is to use something called facet wrap. So facet wrap is really helpful. It allows you to define that same histogram that you used in 2 functions ago, and you can add this one line, facet wrap pitch name. And what that's going to do is it's going to take the pitch name variable, and it's going to segment out a separate histogram for each of those. And so you can see here, oops, there we go. You can see here that we wind up with all these different distributions. And there's one kind of interesting one over here. Somehow the ephus pitch made it in here. I didn't know that people were still throwing those. But again, stuff is tends to make sense, right? You've got fastballs go a lot faster than changeups, curveballs go a little bit slower than sliders, and so on. And I won't show it here, but there's a video. We can show it. It's kind of funny. This is the original ephus from the 70s. It's kind of funny. Kind of embarrassing. I'm a baseball player, so I couldn't help myself. Okay, so what else we got? So if you want to investigate categorical variables, there's a way to make bar plots. It's called geom_bar. I've got this variable called pitch type. That is whether whether a pitch wound up being a strike, a ball, or was a hit. And so you can see here that we've got X representing ball was hit, S that it was a strike, and B it was a ball. You've got roughly more strikes than balls, and then you've got roughly, if you summed the pitches that were hit with the balls, it'd be roughly equivalent to strikes, and that seems to be pretty reasonable. So similar to facet wrap is facet grid. Facet grid allows you to segment variables, but instead of just creating different plots for each one of those variables and just stringing them together in a big list, it's going to actually create a grid layout of both of those, hence the name. So you can see here that you can look at balls, strikes, and hits on the same X and Y axes, and it's just kind of interesting because it can give you a good sense for what everything's doing, and it's all going to be lined up. Other cool part about facet grid is that you can go multi-directional, so you can have two variables going at the same time. So here we've got balls, strikes, and hits, and then in this Y parameter here, we're looking at the different types of pitches. And so it just gives you a little bit more insight into, it seems like strikes that are changeups are okay, they're roughly in the 85-ish range. The scales are a little wonky here, but you kind of get the sense for what you can do with it. So similar to histograms, you have a density plot or a geom density. Geom density is great when you want to compare variables and sub-segments of a particular variable where the counts are a lot different. I'll give you an example. So you look at speed here, you got kind of this distribution of pitch speed, similar to that histogram we saw up top. But then we can look and, we can execute this, almost the same piece of code, except we'll set the color of each one of these lines to the name of the pitch. And then all of a sudden, we've got all of these different distributions, and you can see that, okay, fastballs tend to have the highest sort of median or middle value here, you've got the ephus down here at like 65 miles an hour. And then you can also see that, where's our slider? What color is slider? Pink. There it is. Slider, somewhere in the middle. So good way to get a very sort of high-level view of your data set. All right. So that's sort of the basics of ggplot. Some other features that I really like are we touched on it a little bit earlier, but the statistics, or the stat smooth and the stat identity, those are something that I always found extremely difficult to do in either whether it was base R that I was using or in Matplotlib. And it's a great way to get a really quick and dirty analysis on data. So again, reading in my data here. And we're going to pose a question. So how does pitcher fatigue impact their velocity? Did a little pandas munging here. And all I'm doing is subsetting out each game by date, and then doing a cumulative sum on that field for each pitcher for each game. And what you wind up with is you've numbered what number or how many pitches a pitcher has thrown in each game. Run that here. Alrighty. So what we can do, one thing is we can create a big old scatter plot, and you wind up with this giant mess of points. So that's not super useful. So you know that we can't just look at all these points individually. There's just too many of them. So how can we aggregate, or how can we come up with a way to actually make sense of this? Well, my favorite way is to use stat smooth. So what stat smooth does is it allows you to take a couple variables. In this case, I'm going to plot the pitch count on the x-axis and the velocity of the pitch on the y-axis. And it'll actually compute a localized regression on all of those points that we just saw. And so you can see in this, just as a baseball fan, this makes sense to me. On average, you've got the velocity decreasing as a pitcher throws more pitches. And you can look out to 120 pitches a game. Someone's, your velocity is 3 miles an hour slower. There's a lot of different ways that you can use stat smooth. One is you can just adjust the span. That's essentially how many points are being taken into consideration for the regression. Higher is going to mean more points, lower means fewer points. So I'll drop it to 0.3 here. And you can see you get a little bit more of the noise in your chart. There's also a few different types of smoothers that you can use. One is that you can use a linear method. Oops. Oh, it's going here. You can use a linear method. There's a basic moving average, and then there's the localized regression that I already showed you. All right. So how can we sort of dive in a little bit deeper? Well, instead of just looking at all the pitches aggregated together, because obviously a fastball is going to go a lot faster than a changeup, how can we break that out? Well, if we subset by color and assign that to the type of the pitch that was thrown, you can start to see and break out trends on each one of those. And so sort of the same general idea. You've got fastball getting progressively slower. It sort of tapers off after 100 pitches. It's kind of interesting. Knuckleballs go a little bit faster by the end of the game, which is sort of flipping everything on its head, but it makes sense since the knuckleball, they're trying to limit the spin on the ball. They actually want to throw it as slow as possible. Okay, so we've got all these sort of bigger, more holistic views of the data, but what happens when we actually break it down and start to look at individual players? So I just took a look at, oops, there we go. Took a look and found which pitchers were appearing the most in this data set. David Price came up first, and he's pretty good, so I thought he'd be an interesting guy to take a look at. Run that here. So we can look at him personally. How does his performance vary by inning? So you can see that in general, it looks like in the first inning, he's throwing a little bit harder than he's throwing in the later innings of the game. If you break that down by the type of pitch, again, you get to see fastballs are appearing up close to 95 miles an hour. You've got curveballs down here closer to 80, and then there's kind of like that general downward sloping trend. Again, facet wrap is your friend. You can use this to break everything out individually. And then you can also apply same sort of statistics and get them on it for an individual player. And so very quickly you can see that, like, okay, there seems to be like this clear kind of downward trend for David Price's fastball. Nothing there. All right, I'll skip down here. Okay, and then same sort of plot, segmenting out by pitch count this time. You can see that you've got all these trends. One thing that's interesting that I haven't touched on yet is that if you put aesthetics inside of the ggplot object here, that is going to be like a sort of like a general parameter for your plot. Whereas if you include them directly in the stat or directly in the geom, that's kind of like hard coding a particular aesthetic. So you can see that like the size I'm setting to 8, and that's just like saying, look, I don't want size to actually be attributed to a particular variable. I just want these lines to be a little bit bigger. And then same goes for alpha. I wanted these points to show up a little bit lighter because I really wanted to focus on the trend line and then just kind of have the points be a backdrop for each one of these. So sticking parameters into the functions down here, still going to be there, but they're just going to be hard-coded. And then if any of you are baseball fans, I thought this was kind of cool. I did the same run on the data for Justin Verlander and saw some pretty interesting statistics. I know like Joe Buck always talks about this in the playoffs. He's like how Justin Verlander throws so hard and throws harder as the game goes on. I never really believed him, but it looks like he actually does. His fastball is actually fastest the later into the game that he goes. Kind of cool. Okay, so we've covered how you create a basic ggplot, how you add geoms and stats to those plots. Lastly, sort of I want to cover how you can actually customize and make your plots look a little bit better. So excuse me. Again, loading in this baseball data set. I can look and see the strike zone for every single pitch that was thrown in this time point. Kind of gets a little interesting. You can see that there's this big outer section of balls with the orange. In the middle, you've got that green, which is all the strikes. And then in the very middle, you can start to kind of see a little bit of a hint of purple. And that purple are those pitches that just went right down the middle and got crushed, I'm sure. And so you can look at that. I segmented it out by shape, just to kind of give you a little demo of how you can do that. Shape must be a discrete variable. In this case, I'm using the name or the type of the pitch that was thrown. And so there's a discrete number of, there's a discrete number of shapes. So again, instead of looking at the aggregate, let's sort of drop down and just inspect one particular hitter. I wanted to look at Mike Trout just because he's really good, and he appeared the most times in the data set. So I took a look and I plotted every pitch that was thrown to Mike Trout and where it appeared in the strike zone. So you can kind of see they tend to concentrate towards the middle. Again, you see that ring around of red pitches that were thrown as balls. In the middle there, you've got some strikes, and then, of course, there's some hits here. And so we can use that, and we can actually color code. We can customize the coloration, because I didn't really like the default colors here. So I know there was a demo of it earlier in the Bokeh tutorial, but we also have a scale color brewer, which will define separate palettes for your charts. So you can look at here. The base one is just going to do blues, but you can customize it and say, OK, I have like a qualitative variable. I can assign type to equal qual. You can assign different palettes. So here I'll do, I can do 2. I can bump it up to 3, 4 here, and I'll get a different set of colors, so on. OK, so I thought it would be cool, not just to have all these points here, but actually define the strike zone with a bunch of lines so we can outline it and see what's going on and where all these pitches are actually landing relative to where the batter is standing. So we can use geom hline, and what that will do is it'll create these lines right here, these horizontal lines. I'm going to define them and set them to this variable strike zone bottom and strike zone top. So I can do that, and then sort of on the same vein, I can define vertical lines for the edges of the strike zone. And then lastly, I'm going to set the coordinates to be equal so that 1 foot in the x direction and 1 foot in the y direction are going to be equally represented in the plot. And so you can see here, let me zoom in a little bit. You can see it seems like his sweet spot is sort of in the lower left half of the plate here, and get a lot of strikes around the top up here. Again, there's a lot of different ways that you can adjust the color of your data sets. Here, I'm looking at the speed of the pitch when it is released versus when it hits the catcher's glove. And you can see there's generally like a linear trend, which makes sense. Pitch is fastest when it leaves pitches fastest when it leaves the pitcher's hand, and slowest when it hits the catcher's glove. And then I've just kind of color coded all these points just to kind of provide a visual cue for the magnitude of the change from the pitcher's mound to home plate. This guy here. Oops. Sorry. OK, so another really handy sort of geom that I use a lot is geom AB line. It's just going to define a diagonal line. You can add customize the y-intercept and the x-intercept kind of as you see fit. So for example, I could come in here and say, I want the y-intercept to be set to maybe like 70, maybe like 10. And rerun things, and that's going to just adjust the, whoops. Just intercept. And that'll adjust where the line is going to show up in our chart. Takes a minute here. There we go. OK, so looking at another pitcher, we'll look at C.J. Wilson, just another a little bit more interesting, just to mix it up a little bit here. But you can see that we're looking at how fast he throws pitches and where they show up. And then to define that and actually make it a little more explicit, I can use the xlab, ylab, and ggtitle functions. These do pretty much what you'd expect they do. They define labels and titles for your plot. Everything will default to just showing up as vertical text or horizontal. There's one guy who's working on making it so that you can have like super customizable, like diagonal, like 45-degree angled text in like different fonts. But that'll be in the upcoming release. So again, scaling colors. Another thing that's kind of cool to do that you can customize is defining what colors you want to represent on different gradients. So scale color gradient will take a numerically assigned color field and provide you with a sort of a color map. So instead of doing yellow and red, I'll do like from white to, I'll do black. Kind of boring, but it's okay. And you can see that you've got kind of these gray guys down here, and then you got black ones up here. All right, so what I really wanted to see was for this particular pitcher, how can we take the velocity that he throws across all of his different pitches and kind of compare it so that we can see where he throws fastest in the strike zone for different pitches. So I wrote a little function just to normalize the pitch speed so that it was between 0 and 1, subsetted by the name of each pitch. And then from there, what we can do is we can actually plot it and facet that and define the color to be that normalized pitch speed so that from within each one of these little subplots here, you can start to see where he's throwing fastest, where he's throwing slower. And then if we want to break that out even further, we can just look at, again, this is the same chart, but without faceted, we can look at just sliders. And you can see that he tends to throw hard sliders, kind of like down and in to a right-handed hitter, which seems to kind of make sense for me. But anyways, a lot of cool stuff you can do with color gradient. It's one of those things that's way different than anything that you can do in Excel. And so if you're looking for a quick way to impress your colleagues, I've found it's really effective. All right, so kind of the last thing here is like customizing how your plots look and feel. It's really easy. The next release of ggplot is gonna be even easier. Right now you have to actually implement your own, it's called a theme in the source, but we'll have it so that you'll just be able to like on the fly define a custom theme. But I mentioned earlier Seaborn, they make some really good looking charts. So if I wanted to sort of Seaborn-ize that last chart I just did, all I have to do is add the theme Seaborn function, and all of a sudden I'm going to have a white grid line with gray axis ticks, and I really didn't have to do anything else. Pretty easy. And then, of course, everyone's favorite, you can do XKCD style charts. It looks a little ridiculous in this context, but it's just kind of fun. They look better. I thought they looked better with like a line chart, kind of like this. But yeah. All right, so I've got a couple minutes here, and I'll leave a few for questions, but just want to talk a little bit about kind of what's next, where the project's going. I'll be the first one to admit that there's still plenty of bugs, and ggplot's still really rough around the edges. It doesn't come close to the R version. but the R version's been in development for 3 or 4 years now, and there's a lot of different people working on the project. But that said, I think the first release of ggplot was in October, and we've had at least 30 separate committers, which has been awesome, getting a lot of support, and it's very quickly becoming more and more mature. And the other thing I want to talk about, I think it's really cool, but I haven't actually talked to anyone about it yet, but has anyone seen Matplotlib D3? Yeah, it's really cool. I have no idea how it works, but it converts Matplotlib figures into D3 JSON charts.
So one of the problems I run into with my users is they want to look at their data, but there's always an outlier. Who's the outlier? And then they have to go back and go through their code to try and figure out who the outlier is. You just hover on it.
Yeah.
Yeah, Jake Vanderplas has got a great thing. There's a lot of people contributing to it. It's going to grow fast.
Yeah, and from what I understand, I haven't read through the source, but I've read the spec and I've played around with it a little. You can write plugins for it, so hopefully, everything will either best case it works out of the box and don't have to do a lot of customization, but worst case maybe there's like a ggplot plugin for MPL D3. But I can show you right here. I'm just using the really basic IPython notebook integration with MPL D3. And I can use it and make a little ggplot here, and I didn't run the first command. And this is actually JavaScript. So if I come over here, how do I have to enable this guy here? Whoa. It's kind of cool. You can actually interact with it, and clearly I'm really bad at it, but it works, I guess is the point. I can move over here. Work in progress. All right. All right, so like I said earlier, all the source code's on GitHub. I'm going to post the slides to SlideShare as soon as we're done here. And I just talked about what's next for the project. So I just released some new docs. It was long overdue. And I think they look pretty good. Gotten some good feedback on them. They're still, again, kind of like the whole project, still a little rough, but the goal is to make it super easy to find help, and obviously super easy to find help, but provide a lot of examples for how to use ggplot. You can see that it's going to be pretty simple. Don't have examples yet, but they're coming. So stay tuned for better documentation. All right, so with that, thanks for coming out, learning more about ggplot, and if anyone has any questions, I'm happy to answer them or try my best. All right.
This was really useful for people like us. At least I don't have to run many different grammar of graphics. One is enough, because going back and forth with R and Python is just a mess. I'm just curious, in terms of your coverage, so I see you have pretty much replicated exactly the functionality of ggplot in R. So what are the corner cases where it's not kind of working, just out of curiosity? And
sure. So
go ahead.
And yeah, so the big things, and I was actually talking to someone about this earlier. The tough part is the stuff that's native in base R, that you can't really see the reference implementation or it's all in like C++. R does things like the localized regression is native in R, and so in ggplot it's like, or in Python there's not really a great implementation. Yeah. We actually had a couple people. Trey Cosio was one. He's a great guy, but we had a couple people help out because I'm not as good at the statistics side of things. So that's been something that's been really great. It's just people helping out and pitching in on some of the harder stuff.
Oh, okay, and the last one is, in terms of, I guess the best way to put it is, I'm not able to frame it right now, so maybe I'll think about it.
Okay.
Yeah, so I guess you just answered it, but this doesn't call R in any way, it just runs Python.
So everything's Python.
Okay, because you use a lot of the data sets, like the diamonds and stuff. I'm like, okay.
Yeah, it's a lot of it is from R,
Right.
but it's all in Python.
Okay, so this is mildly tangential, but can you show me the stuff on factors that you had up there?
Yeah.
Because I've been looking for where those live in the Python world, and I haven't found them until.
So they live in, I think they live in the utils file in ggplot. But actually,
I'm wondering if they're a ggplot thing or a pandas thing, or.
Yeah, it's a Patsy thing. So Patsy is this really cool project that doesn't, at least I don't think it gets enough love. It's like an implementation of R formulas and expressions in Python. So it'll allow you to do things like this, where you can define like a regression formula, and then you can actually use that in a library like stats models to build a regression model. So we use that same methodology for doing things like factors and doing arithmetic from within the aesthetics and from within that string where you define what column you want to plot.
Okay, I might have to talk somewhere else, but what I was looking for is basically these enumerations from R. Is that the same kind of factor as here?
Oh, like categorical variables? Yeah, I guess so.
Okay, so you can put these in big tables and stuff?
Okay. I think so. If I'm understanding your question correctly,
I'll have to figure it out.
I think the answer is yes.
I have a question for you. So you use a lot of the plus operator because ggplot does it, overloads the plus operator, I guess. Is that isn't to do that rather than method chaining?
I think so. We've talked about, I think there's a GitHub issue open about doing an object-oriented layering where it's like you said, it's like chaining different things together. The problem with that is that sometimes you wind up with like 10 different things in the chain, and that would be, look, in Python, you couldn't do it like JavaScript where you can like do a new line, so that could be really ugly. But yeah, I mean, it's totally possible. I tend to like the idea of like you're actually adding different layers together, and so it's sort of like a nice sort of like visual cue as to what's happening. All right, well, thanks, guys. Appreciate you coming out. If you have any other questions, feel free to send me an email or something.
So can we give him a warm thank you for coming in and doing this? So we basically have from 3:50 until 4:05, so you can go take a break. Again, if you're going to be heading over to the other location for the next set of tutorials, help us herd you guys into groups so we can get you escorted over there. If you're staying, that's great. Get up, feel free. There's some fresh water and stuff over here. Get something to eat and drink, and we'll get the next session set up fairly soon. Thanks.